Hello friends, in this lecture we will study Crocodile system, one of the earliest train protection systems used in Europe. Crocodile is a signaling and monitoring system under the responsibility of Belgium, France and Luxembourg. It is installed mainly on the mainline railway lines of these countries and represents a basic warning type ATP. Although simple, Crocodile played an important role in improving operational safety and influenced later signaling developments. Crocodile system description. Let us now understand how the Crocodile system works. The system consists of an iron bar mounted between the rails on the track and a brush installed on the locomotive. When the train passes over the bar, physical contact is made between the bar and the brush. The track bar is energized with a direct current of plus or minus 20 volts, depending on the aspects of the signal. This voltage is transmitted to the onboard equipment through direct contact. Crocodile operation. When the train passes over the Crocodile bar, the driver receives a warning indication inside the cab. The driver must acknowledge the warning within a specified time. If the driver fails to respond, the system automatically applies the emergency brake. This ensures that human error, such as distraction or missed signals, does not result in a dangerous situation. Crocodile system key characteristics. It is important to note the limitations of the Crocodile system. The system does not supervise speed or distance. The only supervision is whether the driver acknowledges the warning. If the emergency brake is applied, it can be released only after the train comes to a complete standstill. Because of these limitations, Crocodile is considered a monitoring and warning system, not a full ATP with speed control. TVM system. Now let us move to a much more advanced system, the TVM system. TVM stands for Transmission Voie Machine, meaning track to train transmission. The responsible member states for TVM are France and Belgium. TVM is installed on French high-speed lines and is specifically designed for high-speed railway operation, whether conventional line-side signals are no longer practical. TVM deployment. There are two various versions of the TVM system. TVM 300 used on early high-speed lines such as Paris-Lyon, Paris-Tours. TVM 430, the latest version installed on Paris-Le Calais, LGV Mediterranean, the Eurotunnel and Brussels interconnection. TVM 430 is fully compatible with the TVM 300, allowing seamless operation across different lines. TVM transmission principles. TVM uses continuous transmission, which is essential for high-speed operation. Continuous data transmission is achieved through coded track circuits. Point-based transmission is supported using inductive loops or beacons such as KVB or TBL. Data is transferred to the train via inductively coupled loop antennas mounted above the rails. This ensures constant communication between the track and the train. TVM technical characteristics. Let us look at the technical aspects of TVM. Track circuits transmit data using carrier frequencies between 1.7 and 2.6 kHz with the speed commands modulated using FSK. Inductive loops for TVM 300 use 14 frequencies between 1.3 and 3.8 kHz. TVM 430 use a PSK modulated signal at 125 kHz, providing higher data capacity and reliability. These features allow TVM to support very high operating speeds safely. TVM operation and safety. In TVM, the driver receives visual speed commands directly inside the cab. The system performs continuous speed supervision, stopping point monitoring, and automatic brake application if the train exceeds permitted speed. TVM 300 uses a stepped braking curve, while TVM 430 uses a more advanced parabolic braking curve, allowing smoother and safer deacceleration. If overspeed occurs, the system immediately applies the emergency brake. To conclude, Europe has a wide variety of signaling systems, including sports supervision system like PZB, ASFA, AWS, continuous supervision system like ABCAB, RSDD, full in-cab signaling system like TVM, LZB, TBL, CellCab. This diversity eventually led to the development of ERTMS ETCS, aiming to unify and standardize railway signaling across Europe. Okay, thank you.